I might be in London right now, but that does not mean I've forgotten about you, because tomorrow is GCSE Chemistry Paper 2, so I'm going to be going through examiners' tips, things that are likely to come up, mistakes that you do not want to be making, and just generally giving you some advice that are going to help you raise your grades in this final chemistry paper. Once you've done this paper, for a lot of people, the only exam you're going to have left is physics. So this really is the home stretch right now. You want to be making sure you're maximising your marks. You want to be making sure that you're not slacking off, because there's so little time to go. You can hold on, you can push it. Let's get started. First of all, we're going to be going through some of the likely topics that are going to be coming up. As ever, been through examiners' reports, been through past papers. This is predominantly for AQA and OCR, but obviously it applies to certain aspects of Edexcel as well. So the first topic that is like a big topic on this paper is the rate and extent of chemical change. So that's things like collision theory, thinking about equilibrium. It doesn't generally take up a large amount with the exception of catalysts. And there are a lot of keywords in this topic that you need to know. There are a lot of definition style questions that they ask you. If you're not the kind of person who enjoys definition style questions, which I did not, there are massive glossary sheets on Physics and Maths Tutor that were my absolute saviour. And some very helpful people have turned those glossary sheets into flashcards that you can access on Quizlet. So I would go through and just make sure you can answer them. And it is, particularly with chemistry, examiners want you to be picking up on very, very specific keywords. So you want to make sure that you do know the definitions, not just vaguely, but in the way that uses the exact keywords that they are looking for. Then the second topic is the organic chemistry. Now, this is a high topic, and not a lot of people like this topic. However, we're going to break it down, and these are the parts that you need to know, okay? Fractional distillation, pros, cons, how it works. Chromatography, that's quite simple, you've been doing that for a long time, but make sure you can explain all of the different aspects of chromatography, so why you use certain things, why you take certain steps. That is a crucial thing. In this paper, when you are asked practicals and you have practical questions, you need to not only be thinking about, okay, what are the different variables, independent, dependent, control variables, but every time you say a step, make sure you're also referencing what material, so what equipment you're using, and why you are taking that step. So does it improve validity? Does it improve accuracy? Does it mean your results are more reliable or more repeatable? Whatever it is, you need to be mentioning that, because those are marks and you don't want to be losing those marks. Also included within the organic chemistry topic, you've got your alkenes, alkanes, polymers, making sure that you can draw them. Like, yes, it's kind of annoying to have to draw them, and sometimes it's a bit of an effort to remember them as well, but they are high mark questions for not a lot of work. So I would make sure you do go over them. If you do struggle, there are so many videos online that have acronyms, that have mnemonics, that just have any sort of diagrams and visualizations that can make it easier for you to remember them. And that is a really useful thing to do the night before, or just check it the morning of so it is fresh in your brain and you're going to be able to repeat it in the exam. And then chemical analysis is a big topic, and they love to ask about identifying ions and gases. So that are your flame, those are your flame tests, tests for sulfites, tests for halides, making sure you know every single one of those tests and that you can describe them. And again, in describing them, you say like why, what happens. So if they're asking you about how can you test for a certain ion, okay, you might be talking about the flame test, but make sure you're being very, very specific. You don't just put, oh, use the flame test. You need to say, what do you want to observe in that flame test? What is the actual result that you were looking for? How does that show it? Describe the processes, describe the why, and that's how you're going to be hitting all of the marks in those styles of questions. And that is an area that has not been tested very frequently in recent years, so it is something that is highly likely to be coming up on this paper, so I would make sure you know them off by heart. You've got atmospheric chemistry as well. Now, this is kind of a loose topic area where it's hard to understand exactly what they're going to be testing on, but as long as you kind of know about greenhouse gases, you know ozone depletion, and you can talk a little bit about sort of pollutants, the makeup of the atmosphere, how it actually works, what actually goes on, how the greenhouse gas effect works, for example. They like to use wordy questions, and I think the best thing to do with this is honestly to just have a look at what comes up in past papers, because it is a bit of a wishy-washy area and they don't tend to focus on it too much. And actually last year they didn't put that much focus on it at all. Arguably that means they might put more focus on it this year, but the biggest thing that I would say is find those like whole topic summary videos that exist on YouTube and just watch it for 20 minutes, and that'll basically teach you everything you need, because there's not a lot of application, there's just a lot of memorization in that area. And then you also have using resources. Now, water treatment, just know every single stage of that process, because that is under-tested recently. That is disproportionately likely to come up on this paper. Have a look at water treatment, understand the steps, what it means. I think this is just a higher area though, however. And then they can, interestingly enough, in these sciences, draw upon knowledge from paper one topic areas. You're never going to get a big lengthy question on it, but the underlying fundamental of a certain more exploratory question might rely on atomic structure and bonding, for example. So you need to be remembering those things from the past paper, which I know you might want to have forgotten and you might have already thrown your notes out before, but just make sure it is in the back of your mind. So read over your notes briefly, just to make sure that information is right there. So with those being some of the most common topic areas that are going to be coming up, what are the common mistakes that students make? So I've been through examiners' reports and have basically lifted exactly what the examiners have said. So the first big mistake is in practical techniques and data interpretation. People just do not do this well. And the big thing that comes up is there are always questions when they talk about using test tubes or when they talk about using measuring cylinders, reading from the bottom of the meniscus. So like it'll look like this, the water line in the tube. You need to be reading from the bottom of that, not from the top. I know that sounds simple and that is something that has probably been drilled into you since you were in year 8, but it is so easy to forget about that in the exam itself. So make sure you remember that because examiners go on and on about students getting that incorrect. The second thing is not identifying gases correctly, not identifying tests correctly, and also in doing it, not describing the test fully. So particularly if, for example, you're doing the sort of test and it turns it cloudy, make sure you're using the correct terminology to do that rather than just saying, oh, it turns like a white colour. Like that doesn't help. You need to be using the exact terminology they're looking for. The second big mistake that goes on is calculation errors. So that is as simple as just not writing every single step of your working and missing out on method marks. As with any subject that has any bit of maths, you need to be writing down every single line if you want to be getting every single mark. That is so, so critical. And also in chemistry, never forget your units. Units are almost always a component part of a question in terms of getting marks. It might be a 5-mark question and one of those marks will be for your unit. So even if you get everything perfectly correct and you do your units wrong, you're not going to get full marks. And if you have no idea how to answer the question, but you know what the unit's going to be, write down the units because that mark is separate from the answer. You'll still get the unit mark even if you don't have an answer. So write the units down because that is picking up on some really easy marks that you're definitely going to be able to get. And alongside that, also like rounding too early. So if you have a multi-stage calculation question and you get answers midway through, make sure you continue using the actual exact answer that's in your calculator. You might write down a rounded version. Obviously, if it goes on with 17 decimal places, you're not going to write down every single one of those 17 decimal places in your exam script. But when you're doing the further calculations, you've got to use that exact answer. Otherwise, you get it incorrect and you don't get the error carried forward in terms of like the fact that you rounded it and then got a different result. No, you just get it wrong. So make sure you're using the exact thing. And another thing that comes up in examiners' reports a lot is a misunderstanding of command words. Now, this is interesting because you don't really think about chemistry as having explicit command words, but actually they talk a lot about students not using describe and explain. So when a question asks you to describe, you are only listing things. You only need to state what happens, then what happens after that, then what happens after that, and that is it. But when it is an explain question, they explicitly want you to include reasoning. They need you can say this happens because, this happens why, this happens and so what. You need to be including that sort of those linking things, so you're not just listing, you're also reasoning as to why those things are happening, how those things are happening. And that's the distinction between describe and explain that examiners pick up on all the time, and I do not want you to be getting incorrect. So those are my last minute tips for your GCSE Chemistry Paper 2 exam. I hope it goes really, really well. If you have any questions, do let me know in the comments, and do let me know how many exams you have left until you're done.